A wide range of organisms measure the CO2 concentrations of their environment. Plants, as discussed in the preceding sections, adjust the model apertures to minimize water loss per carbohydrate gain based on carbon dioxide concentrations. Exposure to elevated carbon dioxide concentrations diminishes the model apertures. The anthrax bacterium determines from high external carbon dioxide concentrations of about 5% that it has arrived in the lungs or bloodstream of its mammalian host. It then prepares for dispersal by producing toxic proteins to kill the host and synthesize a protective capsule around itself. Mushrooms elevate their fruiting bodies, their caps, to an optimal height for spore dispersal based on measurements of atmospheric carbon dioxide concentrations. Root and microbial respiration drives carbon dioxide concentrations near the soil surface to above 0.1%. Exposure of mushrooms to such CO2 levels promotes stalk elongation instead of cap expansion. Only when the fungus reaches heights above the soil where carbon dioxide concentrations drop below 0.05% does cap expansion take precedence. Social insects such as ants, bees, and termites detect the location and activity of hives via gradients of carbon dioxide concentrations. Bees also determine whether ventilation in a hive is adequate from carbon dioxide concentrations. If concentrations in a beehive rise above 0.5%, young worker bees orient in the same direction and beat their wings to ventilate the hive. Insect herbivores may monitor carbon dioxide concentrations to identify the most delectable plant tissues. Those plant tissues that are most rapidly depleting atmospheric carbon dioxide are synthesizing the most carbohydrates. For example, a moth that feeds on prickly pear cactus resolves differences as small as 0.00005% carbon dioxide against the normal atmospheric background of 0.04% to locate in the dark the cactus pads that are most active in carbon fixation. This moth is a legend in the annals of biological pest control. Prickly pear cactus had become a major weed in Australia, spreading from about 4 million hectares in 1900 to 24 million hectares in 1920. Mechanical or chemical control measures proved inadequate, and the pear was advancing nearly 0.5 million hectares per year when authorities conducted a large-scale release of cactoblastic moth eggs in 1926. 6 years later, by 1932, most of the thick stands of cactus were destroyed.